Very good morning, my dear students. Let's continue the previous topic called projectile motion. Let me write here. What is our topic of discussion is projectile motion. Okay. So the basics of projectile motion we have already discussed. For example, time of flight we have discussed, which is 2u sine theta by g. What is u? What is theta? Everything. Maximum height of a projectile, which is u square sine square theta by 2g. This is also you discussed. And the range of a projectile, which is equal to u square sine 2 theta divided by g. These are the three expressions we have already done, yes or no, including the basic numericals we have done on this. Let us move to the a deeper level of the concepts. Little deeper. In this projectile motion only, we are going to learn the little deeper level of concepts carefully. But the questions will be asked today and in the next projectile motion class will be based on these equations even. Okay, the questions will be asked from the basic equations as well as the current discussions. Now, what I'm going to draw here is a simple projectile motion diagram. A simple projectile motion diagram. See here. This is what one simple projectile motion. Look at here. So this is my x-axis. This is the y-axis here. This is the origin. So there is a body is projected in this way. Okay. So and can clearly see here. This is what the initial velocity u and the angle of projection is theta. When this is initial velocity u, and I can write this is the component called u cos theta, and this is the vertical component of initial velocity is u sin theta, and this is the maximum height point. Okay, this is h maximum, and the maximum horizontal distance taken by the body is range, and the total time of flight is t. So those expressions only we have discussed here. Now, what I wanted to convey here is number one. Let me write here number one. So what is the change in velocity of a projectile motion? What's the question? What is the change in velocity of a projectile motion? Okay, what's the change in velocity? It's so simple. Change in velocity, I am writing it as delta u bar as a velocity is a vector. Final velocity vector minus initial velocity vector. That's a change in velocity. You know the initial velocity here. What is initial velocity? It's u cos theta I cap plus u sin theta j. Okay, that is initial velocity. And what about the final velocity here? At this point, so the body is striking the ground with this initial velocity, whereas its components also I am writing here. Horizontal component of velocity is constant throughout the projectile motion. It's u cos theta, and this is u sin theta, and it is u. So this is initial velocity, and it's a final velocity. Okay, now let me write your delta u bar is equal to what is final velocity in terms of vector. You can see here u cos theta I cap, and this is negative side. You can see it's a minus j cap, so minus u sin theta j cap. So that is UF bar, final velocity. This is final velocity, and this is initial velocity. Now it's minus, what is the initial velocity? Initial velocity in the vector form, it will be u cos theta I cap plus u sin theta j cap. I hope you could understand the topic called vectors. Now there is no confusion here. All right. So delta u bar is equal to, so what I can write, u cos theta I cap minus the u sin theta j cap minus u cos theta I cap minus u sin theta j cap. Right, step by step. I'm not writing any direct step here. Step by step only I'm writing. So plus u cos theta I cap minus u cos theta I cap cancel. So then delta u bar is equal to minus 2u sin theta g cap. If anybody asked you to find the magnitude of this, so that will be just 2u sin theta. So what is the magnitude of change in velocity, my dear students here? What is the magnitude of change in velocity here? It is 2u sin theta. All right. So like this questions will be. And here, directly by looking at this projectile motion diagram, you can understand what is the change in u cos theta component and u cos theta component. So there's no change here, as velocity is having direction as well as magnitude. Direction you identify u cos theta. Direction you identify this u cos theta. Both are same direction, right? And the magnitudes also you can see it is u cos theta, and this is also u cos theta. So there's no change in the magnitude as well as the direction. So you can conclude that there's no change in x component of velocity. Okay. And the y component you see, one is u sin theta, the another one is u sin theta. You can see the direction is reversed. Direction is reversed here. So definitely when you are finding change in velocity, these two components will be added up. These two components will be added up. So the basic level numericals we have done based on this in motion in a straight line. All right. Clear? Now finally, it's 2u sin theta. That's what I do. U sin theta, u sin theta. As both are in opposite direction, it will just add. So now, here itself, the questions will be asked, what is the change in linear momentum? Question is, what is the change in linear momentum? It's a simple question. What is the change in linear? What is the change? Change in linear momentum is equal to mass into change in velocity. Understand? Because mass, there is no change in mass. You cannot write delta m because mass is constant. The same body is projected from here, and same body is reaching to the maximum height, and the same body is reaching to the ground height. All right. So here, what I can write m into what is the magnitude of change in velocity? It's 2u sine theta. Here itself, 2u sine theta. So if you write here, it will be 2mu sine theta. Clear? All right. That's it. That is a change in linear term. Okay. Now, the next question. See, this is what I just keep on adding. The kind of questions can be expected. The kind of questions can be given in your NEET exam, JEE, FCG exam, and just keep on adding. So change in velocity and change in linear momentum. Sometimes the question will be asked like this. So what is the average velocity of a projectile? What is the average velocity of a projectile? What is the average velocity formula, my dear students? Total displacement by total time taken. Yes, what is that? Total displacement by total time taken. So come back to the diagram here. What's the total displacement? So the particle is initially at this origin, at here. Finally, at this point. So the displacement from the day one, I'm telling you, displacement, when somebody asks you to find displacement, so you should see what is the initial point and what's the final point. So this is my initial point and this is my final point. So to find the displacement, you need to draw a straight line. Straight line between initial point and the final point is nothing but the range of a projectile. All right, so this total displacement is the range by total time taken. It's time of flight. Just divide the range by time of flight, you get average velocity. All right, and let me divide. So V average is equal to range. What is the range expression? See, for this purpose only, I wrote the expression. So u square sine 2 theta is 2 sine theta cos theta divided by g. Okay, into divided by time. So time 2u sine theta by g. If I write in the numerator, this will become reciprocal. So that will be g divided by 2u sine theta. Look at the interesting thing. G cancel here. Okay, now it's 1 sine theta, a sine theta, 2 fabulous e, 1 u, another u. So this complete term got cancelled. So what is remain? The remaining term is only u cos theta. Okay, so what is the average velocity here? Which is u cos theta only. Okay, clear? Just u cos theta. That's the interesting part. U cos theta is the horizontal component of velocity, which is constant everywhere, and average velocity of a projectile is also equal to horizontal component of velocity. Remember, so that means average velocity of a projectile is also constant throughout the projectile. Okay, so this is horizontal component of velocity, which is constant everywhere. Okay, clear? So this is how we can discuss the change in velocity, average velocity, and change in linear momentum. Okay, now let's have a look at the next important area of our discussion is energy of a particle at different locations throughout the projectile motion. Okay, so energy of a particle at different location throughout the projectile motion. Okay, so let's take this. Y-axis and x-axis. Just for your better understanding, I'm just drawing a rough diagram here. At this point, initial velocity. So initially at the origin, what is the total? What is the total energy here? So can I say the total energy is equal to half mv square? Energy is a scalar quantity. We need to concentrate only about the scalars, my dear students. Energy is a scalar quantity. We need to concentrate only scalar. So that means only magnitude we need to consider. So the magnitude of this is half mv square. So this is what the total energy at the origin. Okay. So this is what I can write. The total energy at the origin. At origin. Like just after thermal. One important thing you should understand, so according to law of conservation of energy, right, what I can say, total energy always remains constant. There won't be any loss or gain of energy. At any point, you can say, at any point, the total energy will remain constant. At this point, you can say, and at this point, you can say total energy remains constant. So my question is, this is the maximum height, all right? So this is h suffix max. At the maximum height, what is the velocity possessed by the body? It's u cos theta, okay? At the maximum height, only velocity is this. Which is the energy associated with velocity? Potential energy? Potential energy? No, kinetic energy, because it's half mu square. So let me write, see, at maximum height condition, right? What is the kinetic energy? Ek. What's the kinetic energy? Half into m into, so what is the velocity square here? It is u cos theta square. So carefully see, half into m into u square cos square theta. That is the interesting part. So at the same maximum height, so what is the total energy? Now tell me, this interesting part. What is the total energy? As the total energy is constant, so is it equal to half mu square? Yes, it is half mu square only. Okay. Now, total energy at the same maximum height, once again, look at here. So the total energy is equal to kinetic energy plus potential energy. Understand? Kinetic energy plus potential energy. What is the kinetic energy here? Half m u square cos square theta plus potential energy. Okay, plus potential energy. Here comes an important point. And let me write the total energy here. Half m u square, which is equal to kinetic energy is what? Half m u square cos square theta. So plus how much must be this value so that the total energy will be half mu square? That's my question. Just pause the video, write your answer, and send me through WhatsApp, my dear children. That's my question. What must be the what must be the term here so that the total energy will be half mu square, right? I'm writing the answer here. Half m u square sine square theta. Understand? So now you just add these two. You get half mu square common here, half mu square common here. Half mu square is common into cos square theta plus sine square theta. So you know cos square theta plus sine square theta is equal to 1. Okay, so finally you get half mu square. So this is how we get at the maximum height. Potential energy is half mu square sine square theta. Kinetic energy half mu square cos square theta. Okay, at the maximum height, same topic here, same topic at a maximum height, maximum height. So what is the ratio of potential energy to the kinetic energy? What is the potential energy here? Half m u square sine square theta divided by kinetic energy half m u square cos square theta. Half mv square, half mu square. So potential energy to the kinetic energy ratio, which is tan square theta. What is that? Tan square theta. So this is how sometimes the numericals will be asked. You must be ready for all these kind of numericals. All right. Clear? I hope you are understanding and following the topics. Now, what is the topic of discussion nowadays? What is the topic of discussion now? Is relation among time of flight, maximum height, and range of effects. So one or two relations, I just prove them later on. I just give the relations, you need to check whether they are correct or not. So let me give you the first relation here. Your maximum height is equal to 1 by 8 times g t square, right? What is that? What is this? Maximum height is equal to 1 by 8 times gt square. So let us write 1 by 8 into g into t square. What is t square? It's 2u sine theta, right? 2u sine theta by g whole square. Okay, so let's write 1 by 8. See, what is the answer we need? Answer we need that must be equal to h. 1 by 8 into g into 2u sine theta whole square. So that is 4u square. So that is 4u square sine square theta divided by g square. Okay, so 1g cancel. So this is a 4 and this is 2. So what is remained, my dear students, here? Numerator it is u square sine square theta divided by denominator 2g. Is it maximum height? Is it maximum height? Yes, this is an expression for maximum height. So this relation is correct. Remember, h is equal to 1 by 8 gt square. So question will be asked, which among the following relation is correct between h and t? Between h and t. Like these questions will be asked. H is equal to 1 by 8 gt square. So the same thing I can also write t square is equal to 8 into h by g. Okay, so from here, so t is equal to root 8h by g. Like this also questions will be asked, which among the following relation is correct? But mainly this equation, most of the times based on this equation, questions were asked in 8 J and C. Mostly, okay, based on this relation, questions were asked. H is equal to 1 by 8 gt square. All right. Let's look at the another relation. Right? So the another relation is tan theta is equal to 4h by r. Okay, so let me write 4h by r. So 4 into h. H is what? The u square sine square theta by 2g into r. So this r I'm writing in the numerator. So that will be g divided by u square sine 2 theta. Okay. So g cancel here. So this is 2 also cancel here. So this I can write it as so this I can write it as 2u square sine square theta divided by u square 2 sine theta cos theta, because sine 2 theta is 2 sine theta. So 2 cancel. So then u square cancel. 1 sine theta cancel. What is that? Sine theta by cos theta. It's tan theta. All right. Clear? So tan theta is equal to 4h by r. What is that? 4h by r. So 4h can be written as r tan theta. Okay, 4h is equal to r tan theta. And one more, this 4 is equal to 4 into 1 by 8 gt square. Just now I told you, right? So the maximum height and the time of flight relation, 1 by 8 gt square. So which is equal to r tan theta. So this is 4 2s. So 1 by 2, the gt square is equal to r tan theta. And this r tan theta is equal to 4h. All things are correct. All the things are correct here. All the things are correct, right? Okay? So half gt square is equal to r tan theta is equal to 4h. Remember this relation. So like this. So some more relations which are classwork relations I am going to give you now. All right. So we know. See, prove for theta and 90 minus theta, ranges are same. Okay, so these theta and 90 minus theta both are called complementary angles. What are those called? Both are called complementary angles. So for complementary angles, theta and 90 minus theta ranges are same. Right? For example, R1 is equal to u square sine 2 into theta by g, and R2 is equal to u square sine 2 into 90 minus theta by g. So ranges are same means R1 is equal to R2 we get. Same way for the same complementary angles, look at here, for the same complementary angles, theta and 90 minus theta, my question is find h1, right? And h2, you know, the maximum height expression, okay? Maximum height expression. So we also wrote here, this is the maximum height expression. So h1 you find, h2 you find. So now you identify the relation. h1 plus h2 must be equal to u square by 2g minus 2h. So this is the class work you need to find. Okay? Clear? Now, same. This is the class work. And prove this also. R is equal to 4 root h1 into h2. So prove this also. This is also a class. And the same R is equal to 1 by 2 into g into t1 t2. Prove this also as a class. Are you getting the question? Are you getting the question? R1 means when theta is theta. R2 is when theta is 90 minus theta. Same thing. H1 is when theta is theta. H2 is when theta is 90 minus theta. Okay, here also. T1 when theta is theta, T2 when theta is 90 minus theta. To prove this relations, simple left hand side is equal to right hand side. Just prove it. Alright. So these are some kind of relations where questions can be asked. Right? So we move to the next, the last topic for today's session. It's a simple topic, my dear children. We have equation of a projectile. We have the equation of a projectile, which is y is equal to, what is that? Tan theta into x minus g by 2u square cos square theta into x square. Okay, this is ax minus bx square. Look at the interesting part. What I'm going to do is, so y is equal to, I'm just taking common x tan theta. This complete thing I'm taking common. So this term is 1 minus g by, so this is anyway, I'm writing g x square. Okay, g into x square divided by 2u square cos square theta into x tan theta is not there in this expression. Okay, but still we took common. So that is why I am writing x into tan theta. Okay. So what we need to do is, so we just multiply this term inside. Inside there are two terms. Individually you multiply, you get the same expression. Okay, so no confusion. We are not wrong. So here 1x and 1x. Okay. Y is equal to x tan theta into 1 minus g x divided by, means right here, it's 2u square cos square theta into tan theta. I can write sin theta by cos theta. Carefully. Very important expression, very important application we are going to do. Very important application. 1 cos theta, 1 cos theta cancel here. So what is left? Y is equal to x tan theta into 1 minus. So this x I am writing here divided by. So this is the part I am writing in this way. You can see u square 2 sin theta cos theta. This 2 is going to cancel. 2 sin theta cos theta is sin 2 theta divided by this g I am writing here. G. Is there any change in the expression happen? Never. Okay. So y is equal to x tan theta into 1 minus x by. So this is the expression is not the range. So if you want to write this in terms of range, so remember this expression. Y is equal to x tan theta into 1 minus x by r. X tan theta into 1 minus x by r. So this is a very important language, important expression for solving the further. Very important expression. Okay. Now, well, so there is an important note. Okay, we can derive it, but not required for us. Simple. So this is the projectile. This is the maximum height. Right? At maximum height, we have velocity, which is u cos theta only. Question is, this is the height, which is maximum height by 2. That means at half of the maximum height. Understood? At half of the maximum height, so what? At the half of the maximum height, what is the velocity? That's a question. What is the velocity? Right? So velocity is equal to u into square root 1 plus cos square theta by 2. at half of the maximum height, the velocity of the projectile is u into 1 plus cos square theta by 2. Try to remember, because to derive these takes so much of time. Velocity of a projectile at half of the maximum height is u into square root 1 plus cos square theta by 2. Okay, so now the questions for your assignment today can be based on time of flight expression, range, and maximum height, relations among them, including today's class. Just you have enough time to prepare. Just all the very best for your assignment. See you soon.